Higher education faces massive regulatory pressure from the European Union's AI Act. Institutions are legally mandated to integrate AI literacy across their academic programs. Yet, looking at the data from Germany as a representative sample, the academic machinery is slow to respond. Only 31.6% of higher education students report that AI literacy is explicitly addressed in their degrees. The primary bottleneck causing this failure is conceptual ambiguity. Administrators are tasked with teaching a subject that lacks a clear operational definition. Many universities attempt to check the compliance box by running basic how-to workshops. They approach generative models as simple software tools, instructing students on which buttons to click. Because of this, AI interventions remain isolated. A computer science professor might teach algorithmic logic, while a philosophy department hosts an optional seminar on bias. There is no systemic, institution-wide curriculum. Without a concrete framework defining exactly what competencies students need, universities remain paralyzed, leaving their policies disjointed and legally vulnerable to new compliance standards. Solving this implementation gap requires moving past the concept of discretionary tool adoption. Effectively navigating these systems requires treating AI as orchestrated epistemic mediation. Under this definition, AI is a multi-layer socio-technical stack. Its infrastructure, recommendation logics, and probabilistic generation reconfigure how we design instruction, evaluate feedback, and legitimize academic assessments. You cannot measure a student's grasp of a socio-technical stack with a multiple-choice quiz on ethical vigilance. Administrators need an entirely new matrix. Researchers from the University of Passau have proposed exactly this: the AI Literacy Heptagon, a structured, 7-dimensional framework designed to audit and map degree programs. Approaching AI as a socio-technical stack provides universities a concrete way to establish specific, testable competencies across every department. A common misconception among administration is that AI literacy falls neatly under the umbrella of general digital competence. It does not. Take computational literacy. Understanding algorithmic logic and basic programming structures is highly valuable, but writing code is a separate skill from navigating the output of a trained neural network. The same applies to data literacy. The ability to handle raw data and apply statistical methods does not guarantee a student understands how a generative model synthesizes that data into new formats. This Venn diagram maps out the overlaps. Data, computational, and media literacies intersect with AI literacy to build digital competence, but AI occupies its own distinct quadrant. It requires unique skills, navigating probabilistic generation, collaborating in workflows, and critically evaluating opaque system decisions. Because of this delineation, a student can graduate with advanced Python skills or perfect statistical analysis and still remain functionally illiterate regarding the societal and ethical implications of the AI systems they build. To map a university curriculum, we have to construct the operational framework around 7 distinct axes. Most traditional models cover 4 baseline dimensions: technical knowledge, application proficiency, critical thinking ability, and ethical awareness. Stopping at these 4 dimensions leaves massive gaps in a modern higher education context. The 5th dimension is integration skills. Students must know how to incorporate AI into existing organizational workflows, redesigning processes to accommodate human-AI collaboration. The 6th is social impact understanding. This is the capacity to evaluate the long-term economic, political, and structural effects that AI implementation will force onto specific populations. The 7th, and frequently most ignored dimension, is legal and regulatory knowledge. AI does not operate in a legal vacuum. Students have to navigate a highly fragmented landscape, balancing new AI-specific laws alongside established technology-neutral frameworks like GDPR regarding copyright and data protection. Omitting the integrational, social, and legal dimensions produces graduates who are technically capable but organizationally and legally dangerous. Defining these 7 axes introduces a new measurement problem. Curriculum developers have to quantify how a student progresses from a complete novice to an industry professional. We solve this by mapping Bloom's taxonomy onto the heptagon as concentric rings. The innermost levels, unaware and beginner, represent the basic cognitive processes of remembering and understanding concepts. Reaching this beginner ring across all 7 dimensions is the absolute minimum universal baseline required for every single university student, regardless of their major. The outer rings, intermediate and expert, align with advanced cognitive functions, applying, analyzing, evaluating, and creating entirely new AI solutions. Progression into these outer rings is strictly domain-specific. A software engineer requires different expertise than a social worker. Not every student needs to hit expert on every axis. This dual-track system, a universal beginner baseline paired with targeted domain-specific expertise, translates a vague regulatory mandate into a highly scalable, testable institutional policy. To see how this architecture exposes real structural vulnerabilities, we can audit 2 actual degree programs. This radar chart maps a master's in AI engineering. It pushes students into the expert ring for technical knowledge and application proficiency. But the matrix exposes critical vulnerabilities, hovering at mere beginner levels for ethical awareness, social impact, and legal knowledge. In the real world, this specific program produces engineers who can confidently build and deploy advanced generative systems, but who are entirely incapable of ensuring cross-jurisdictional compliance for those exact systems. Under stringent new frameworks like the EU AI Act, these academic blind spots leave both the graduate and the institution legally exposed. Even the most rigorous, highly technical AI degrees will fail a comprehensive audit if they neglect the socio-legal dimensions of the stack. Compare this against a media pedagogy curriculum. It shows different strengths, pushing outward in ethical awareness and critical thinking. Yet, it fails to progress past the beginner level in integration skills and legal knowledge, demonstrating that AI literacy manifests as a variable, discipline-specific topology. This reveals a clear strategic directive for higher education leadership. Institutions must immediately abandon the generalized, university-wide tool workshops that only skim the surface of basic application proficiency. Instead, administrators should deploy this 7-dimensional matrix to conduct formal competency audits, mapping out the exact nodal gaps hidden inside every department's syllabus. Achieving institutional AI literacy requires embedding domain-specific AI orchestration directly into the core learning outcomes of degree structures. By tracking these 7 dimensions, universities can transform a vague legal mandate into a rigorous, measurable academic reality.